This lesson is on the Pythagorean theorem converse. We know that if a triangle is right, then a squared plus b squared equals c squared. Or the sum of the square of the legs equals the square of the hypotenuse. So, the Pythagorean theorem says if a triangle is a right triangle, then a squared plus b squared equals c squared. So the converse is just the opposite of that. So if a squared plus b squared equals c squared, then the triangle is right. And we can use the converse to prove whether or not a triangle is a right triangle. So essentially, if the two shorter sides squared and added together equal the longer side squared, then we know it's a right triangle. So let's look at an example. My right angle is here, or I would presume it to be there. My shorter sides are 30 and 15. So I've got A, B, and C. So 30 squared plus 15 squared has to equal 45 squared if it's going to be a right triangle. Well, 30 squared is 900, and 15 squared is 225. 45 squared is 2025. $900 plus 225 is going to give me 1,125. So since these are not equal, it's not going to be a right triangle because 30 squared plus 15 squared does not equal 45 squared. So if a squared plus b squared does not equal c squared, then it is not a right triangle. Looking at example number 2, my two shorter sides are 15 and 12, so they're going to be my legs. My hypotenuse would be 21. So 15 squared plus 12 squared has to equal 21 squared in order for this to work. So 225 plus 144 has to equal 441. Well, this gives me 369. So these are not equal. So this is not a right triangle because a squared plus b squared does not equal c squared. Let's take a look at example number 3. I've got 18, 24, and 30. 18 and 24 are the two shorter sides, so I know that 30 is going to be the hypotenuse. So 18 squared plus 24 squared has to equal 30 squared if this is going to be a right triangle. So that's 324 plus 576 has to equal 900. Well, 324 plus 576 is 900. These are equal to each other. So this is a right triangle because 18 squared plus 24 squared equals 30 squared. So if it works, if the Pythagorean theorem works, it's a right triangle. If the Pythagorean theorem does not work, it is not a right triangle. Now we're going to look at deciding whether or not a triangle is right just by looking at the side length measurements without a diagram. So it's important to remember that legs are the two short sides, or the smaller numbers, and the hypotenuse is going to be the longer side, or the largest number. So if I look at this first problem, 12, 24, and 36, well, 36 is the longest, and 12 and 24 are the shortest. So 12 squared plus 24 squared would have to equal 36 squared for this to be a right triangle. So 144 plus 576 would have to equal 1,296. Only this actually equals 720. So this is not a right triangle because a squared plus b squared did not equal c squared. Try the next couple problems on your own and then come back to review and see if you got your answers correct. Let's take a look at the next problem. I've got 16, 9, and 11. Of those numbers, 16 is the largest, so that's my hypotenuse. So I know that a squared plus b squared has to equal c squared. 9 squared is 81. 11 squared is 121. 16 squared is 256. But 121 plus 81 is going to give me 202. So this is not going to be a right triangle because 9 squared plus 11 squared did not come out equal to 16 squared. In the next one, 20, 29, and 21. 29 is the longest, so the other two sides are going to be my legs. So 20 squared plus 21 squared would have to come up equal to 29 squared. So that's 400 plus 441 would have to equal 841. Well, this is 841, and this is 841. That works out. So this is a right triangle because 20 squared plus 21 squared equals 29 squared. In the last problem in this set, we've got 12.5, 7.5, and 10. The longest side is 12.5. So I'll have 7.5 squared plus 10 squared equals 12.5 squared. So 7.5 squared is 56.25. 10 squared, of course, is 100. And 12.5 squared is 156.25. So here I end up with 156.25 and 156.25. So that is indeed a right triangle because the Pythagorean theorem worked, and 7.5 squared plus 10 squared is equal to 12.5 squared. Now let's take a look at some word problems. Jimmy thinks a window frame in his house looks slanted because the corner doesn't appear to be a 90-degree angle. His wife disagrees. They measured the window and found the width to be 25 inches, the height to be 36 inches, and the diagonal distance to be 45 inches. Who's correct? So let's draw our window. And I know that the height was 36, the width was 25, and the diagonal was 45. And if this is going to be right, I can use the Pythagorean theorem. So I have my two legs and my hypotenuse. So 36 squared plus 25 squared would have to equal 45 squared in order for this to be a right triangle. So 36 squared is 1,296. 25 squared is 625. 45 squared is 2,025. On the left side, this adds up to be 1,921. But that is not equal, so Jimmy is correct. That is not going to be a 90-degree angle in that corner because that is not a right triangle. Number 6 says, Patty wants a triangular garden in her backyard to grow vegetables. She plans to use 3 pieces of edging that measure 7 feet, 10 feet, and 8 feet. Will her garden be in the shape of a right triangle? Why or why not? So she wants a triangular garden. She's got 7, 10, and 8 feet measurements. The longest of those is 10, so I know that would have to be the hypotenuse. And 7 and 8 would have to be the legs. So if this were going to be a right triangle, 7 squared plus 8 squared would have to equal 10 squared. So 49 plus 81 would have to equal 100. Well, 49 plus 81 is 130. Those do not equal, so her garden will not be in the shape of a right triangle. Because 7 squared plus 8 squared does not equal 10 squared. This last problem is kind of tricky. The perimeters of 3 squares are shown below. Could the 3 squares be positioned so they meet to form a right triangle? Why or why not? So the first thing I have to do is find the side lengths of these squares. So they gave me the perimeter. Well, I know that to find the perimeter, you add all 4 sides. In a square, all 4 sides are the same. So I can divide the perimeter by 4 and get the side length. So here we have our side lengths. 48 divided by 4 is 12. 140 divided by 4 is 35. 148 divided by 4 is 37. My longest measurement is 37, so that would have to be C. So 12 squared plus 35 squared would have to equal 37 squared. So that's 144 plus 1,225 equals 1,369. If I add that up, I get 1,369 on both sides. So yes, these squares could be positioned to form a right triangle because 12 squared plus 35 squared equals 37 squared. So all in all, to decide if a triangle is right or if a triangle could be right, plug the measurements into the Pythagorean theorem. Keep in mind, A and B, or the legs, are the shorter sides. C, the hypotenuse, is the longest side.